All right, now we're doing 7Q, find all non-consecutive numbers. This is by the Codewars, and 92% of people like it. So our task is to find all the elements of an array that are non-consecutive. A number is non-consecutive if it is not exactly one larger than the previous element in the array. The first element gets a pass and is never considered non-consecutive. So we're going to create a function named all non-consecutive. Ergo, if we have an array like this where 6 is after 4 and 15 is after 8, then 6 and 15 are non-consecutive. We should return the results as an array of objects with two values, I for a key and the index of the non-consecutive number as the value, and in as the key and the non-consecutive number as the value. All right, so ergo for the above array, the result should be like this. I is 4 because 0, 1, 2, 3, 4. And then we're also going to have I is 7. So 4, 5, 6, 7 right here. All right, and it's going to have 6 and 16 as the numbers. So if the whole array is consecutive or has one element, then we're going to return an empty array. The array elements will all be numbers. The numbers will also all be unique and in ascending order. The numbers could be positive and or negative, and the gap could be larger than 1. And then here's another kata right here. All right, so first things first, let's do the console.log r, just to see what it looks like. It's probably going to look exactly like this, and it does. All right, so what we want to do is we're going to want to iterate through this thing and see if this number or this number, but this one, we get a pass on this one like it says right here. The first element gets a pass and is never considered. So we're just going to have to see if this is one greater than the one before it, and so on for all the way to the end. All right, so what we're going to do here is we're going to say for let I equal 0 while I is less than r dot length. We'll say I++. Then we're going to say down here, we're going to compare what's at r at I to the previous one before it. So we're going to say if r at I does not equal r at I minus 1 plus 1, all right? So if this number does not equal if this number does not equal this number plus 1, so this number plus 1 is 5, and this one is 6, so they do not equal, what we're going to do is we're going to say, first we're going to come up here and say, let result equal an empty array. Then we're going to come down here and say, result.push. And since we need it to look like this, what we're going to do, let's just copy this. We'll copy this and put this in there and say right here, I will be I, and in will be r at I. Just like that. And then we'll just return result down here. Let's do console.log result to test it. All right, and it looks like this right here. So we got to make sure, we got to get rid of this 0 somehow. And the way we get rid of this 0, since it's not part of the answer, we're just going to turn this into 1 like that, because no matter what, the 0 is going to be on there because it's always different than nothing. All right, so we've got this right here, and it looks like this right here. So let's turn this into return result, test it out, and there we go. And attempt it, and there we go. Awesome, awesome. But you know what? The thing about this is that sometimes we may find ourselves in situations. What did I just do there? Okay, in situations. Okay, let's do that. Where we're going to have something that's really hard to read in front of us, or we're going to want to make something that's hard to read. Whatever the case may be, there is definitely a way to do this one-liner style. So let's say const all non-consecutive equals R. And then let's have an arrow right here doing arrow function syntax. We'll say console.log right here so we can test while we go. And we'll start right here with the R just like we've been doing. All right, so we got R right here. And first method we're going to use the reduce method, which basically, let's just go up here, I'll tell you about it. The reduce method executes a user-supplied reducer callback function on each element of the array in order, passing in the return value from the calculation on the preceding element. The final result of running the reducer across all elements of the array is a single value, believe it or not. Another important thing is that the first time that the callback is run, there's no return value of the previous calculation, but if supplied, an initial value may be used in its place. Otherwise, the array element at index 0 is used as the initial value, and iteration starts from the next element, index 1 instead of index 0. Now, if this is your first time and you've never seen this before, well, this is very difficult because I know if you see the first video that I did with reducing it, I was like, oh, what? And we can't even do this right here. So let's just watch this like it's a Bob Ross painting or something. Just watch as it works, okay? So the syntax we're going to use is this reduce accumulator current value and current index thing, but not this one. We're going to use this one down here. My bad. Accumulator, current value, current index, and an initial value, all right? So the accumulator, think of it like this. It's just like the result, okay? The initial value is like saying result equals an empty array, okay? Current value is going to be the in, and then current index is going to be the I. So we're going to do a what is that thing called? We're going to do a function inside of this reduce method, all right? So let's come over here, say r dot reduce, and we're going to say what was it? R for result. We're going to say in for the whatever is the current element, like this one, any of these, and then I for the index of that element. All right. Then we're going to have the arrow right here, and we're going to start off by doing something pretty much exactly like this. In fact, so much exactly almost, we're going to do this and just change this into in. So if in equals, and then it looks at this R at the index that in is at, -1 plus 1. So it does exactly that. So we're going to say if this is the case, we're going to do something. But we're not going to use the if, else, or anything like that. We're going to use the ternary operator, or the conditional operator, which is the only JavaScript operator that takes 3 operands. A condition followed by a question mark, then an expression to execute if the condition is truthy, followed by a colon, and then finally the expression to execute if the condition is falsy. And this operator is frequently used as an alternative to an if-else statement. So what we're going to do here is, this is our condition right here. Then we're going to say it's going to be followed by a question mark, and then we're going to have the expression to execute if this condition is truthy, which is pretty much going to be just like this here. So how are we going to do this? That's the question. Let's just do something like this, just to start. Let's do this, and let's say I, comma, in. All right? I don't think we even need to do any. I wonder if we... yes, that's cool. Anyway, so I and in right there. Now let's test that out just to see what it looks like. Okay, nothing first, because this is what we want it to do. If it's truthy, if it's falsy after this colon, we want it to be R. Okay, we want it just to return the result. So now let's test it out, see what it looks like. Okay, so now we've got an array, an object where we've got I is 7 and in is 10. When we need something like this, which is in an array, this is two objects in an array, and there's 2 of them, and that's pretty much it. So as you can see here, the last element is this one, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7, and that's 10. So because it's doing reduce, it just takes the last one since we didn't really do anything to it. So to get it into this array, let's just throw brackets around it to start, all right? Let's see what happens. Test that out. All right, brackets good to go. Now we need something in front of it because this is clearly the last one. So we want it to do all the calculations. So All the calculations before this would be R, right? It would be the result from the previous calculations, right? So let's just put R in there and see what happens. Test that out. Okay, so we've got 1, we've got this, and we've got this, okay? But this is in, as you see, these are in its own brackets, and, excuse me, these are in its own brackets inside of these brackets. So that's not looking too cool right now. Main reason because we need to use the spread syntax to unpack this array right here that starts with this. We need to unpack this array and put it inside this array, okay? So to do that, we're going to use the spread syntax, which allows an iteral such as an array or string to be expanded in places where 0 or more arguments or elements for array literals, that's what we're making, are expected. So since this is an array literal, we'll just put it in front of this R, ... and it should take away all these brackets. Let's test it out. R is not iterable. What's up with that? Why is that the case? Mainly because we don't have an initial value here. See, it's just throwing the 1. You see this 1 right here? You see this 1 right here? That's this 1. But when we unpack it, it's not able to go. The first 1 isn't able to go in there. So we're just going to have to do something like this. We're going to say comma, and then we're going to have these this thing right here. What's the deal here? This better work. Okay. Oh, there's only 2 dots. 3 dots. How about that? I was about to get real heated right there. All right, and then here we go. So now we've got this one here, but we've still got this one here. Okay, so I guess it didn't have too much to do with the initial value being 1 because the 1's still there. I think that we have to probably get rid of this 0 because it's at index 0. But how do we do that? We could say something like this. We could say in front of this one, as part of the condition, I cannot equal 0 and this stuff as well. Now let's test it out. And there it is. It now looks good. But you know what? We don't need all this because we just need I to exist. Okay? Because if it's 0, it doesn't exist, right? Let's test it out. Still the same. Awesome. So let's take this out of here like thus. Put it up here. Test it out for real. All right, and attempt it. All right. But you know what? Do you know what? That ain't the only way we could do it. We can do it another way and actually make it a little tiny bit more concise, believe it or not. So let's just get this right here. Let's go like this, just like that right there. Let's bring this console.log, throw R back in it, do the old song and dance, same old song and dance, and there we are right there. But this time we're not going to be using reduce, we're going to use the map method. And if you don't know about the map method creates a new array populated with the results of calling a provided function on every element in the calling array. So with this array, array 1, which is all these numbers, we're going to call this function on each one of these. The x is going to represent each one of these elements, so we're going to say times 2 on each one of them. So 1, 4, 9, and 16 is going to turn into 2, 8, 18, and 32. Let's run it, and it's just like that. All right. That being said, we're going to say r.map. And you know what we want to do to each one of these arrays? Well, first, each one of these elements. First things first, let's get this in and I in there. So we're going to come back over here to the map page right here. And we're going to use this syntax right here where it's element and index right there. So instead of element this time, we're going to say in again because it's easier for us to remember, comma, I, like that. And just like we did here, exactly like we did here, we're going to take this and we're going to put this here. And as you remember, as long as we do this, it'll just put this in there since we're doing it arrow function style. Now let's test this out. Uh-oh, bunch of undefines. What's the problem? Well, there's a little thing about arrow functions, all right? So we got to do something, and this isn't even easy as I'd like either. So we're going to have to do a control F on this page, and we're going to have to say object literals. And that's what we're making right here. We're making object literals. But see, returning object literals, using the concise body syntax, that's what we're doing, does not work as expected. See, if we do this, it returns undefined. That's what we did. If we do something else, it does an error. And if we do this, it'll do an error. So to fix this, we're going to wrap the object literal in parentheses. And now let's read this too. This is because JavaScript only says, let's not read that. To fix this, what we're going to do is wrap the object literal in parentheses. We're just going to put parentheses around the object like thus. So now we know next time this happens, we'll just slap some parentheses on it. No big deal. Test it out. And there's the proof. Now you see we've done to every single element, we've made them all objects. Okay. So now what are we going to do with that? What's up with that? Good thing you asked. We're going to say dot filter. All right. And we're going to use the filter method on it. We're going to filter out everything that isn't a case just like this, where the this in is more than one greater than this in. Okay. So let's go over to the filter method just in case you need a refresher or haven't seen it before. And this creates a shallow copy of a portion of a given array filtered down to just the elements from the given array that pass the test implemented by the provided function. Okay, so here's an array right here. We're saying give me all the words that have a word dot length greater than 6. So like this one, this one, and this one. And you see we've got a new array with all of them that have the length greater than 6. These ones are taken out. So what we want to do is we want to make it to where it takes all these out and these out and just leaves these odd ones, these crazy ones for us. All right, so we're going to say here in the filter, we're going to do the same in and I, right? So we're going to do in I. Whoops, let's wrap that in parentheses. I almost forgot. In and I. And then we're going to do this right here. And let's just go back over here and we're using this element index syntax just like that. And then right here, what we're going to say is pretty much just exactly like this right here. So let's take this, bring it up here. All right, let's just test it out just to see what happens. Okay, so it keeps doing this. What's the deal with that? Well, basically because objects need to be accessed with a dot value, dot key to do it. So we're going to say in dot in. Okay, but let's, since that's a little confusing for us, let's say E. Let's call this E. So it's this element dot in, which in this case would be 2, 3, 4, 5, 6, 7. And we're going to see if this is the case. Let's see what happens here. Look at that. Look at that. What is the deal? Usually it's the same on this one. What's the deal with that? Where did I add a space? Oh, the space is right here. Awesome. So you see this. Let's take this. No, let's take this. Bring it up over here just to test it. All right, and attempt it. And wouldn't you know it, it works too. So you see we saved a total of one single space by doing 2 methods on this one. And now we know a little bit more about concise syntax and being able to read stuff that's hard to read. And maybe even one day we'll be able to go from concise syntax to easy to read syntax. Let's test it one more time. Attempt it and submit it. All right, and so you see right here, this person, Ryan J. Mac. Oh my goodness. Anyway, this guy used for each. There we go. And and you can check that out and analyze it and figure it out. This one used the for loop like we did, except for they did it a little bit different. This one used the map method. This one used the reduce method, and you can just check out all the rest if you feel like it. Let's go over to mine. Just me right here. Best practice in my opinion. Very much like it. And we'll see you next time.